Hi folks, welcome back to our rational roots work in section 2.4 and 2.5. We ended class with this example and we found that your possible rational roots were 1, 2, 3, 4, 6, 8, 12, and 24. We also found that the number 2 worked, so I'll just go through this as a quick review. The 2 worked, and don't forget we had to put in a 0 for the x cubed term. So 0 here, -6, -8, and then 24. With a quick synthetic division, we can see that we're going to end up with a 0 remainder. This is here 2. Don't forget I'm multiplying there, yeah? 2. And then a 4, -2, -4. Again, this is just a quick multiplication and add, and that gives us our 0 remainder. And we know we like that because now we see that we have this cubic. So on the side, I'm going to write the cubic that we have, x cubed plus 2x squared minus 2x minus 12. And that's the answer, or the quotient, when we divide by that x minus 2. But I'm going to keep right on working here and see if we can find other values that might work. And keep in mind now that's it's a 12. That's in the end not a different value. So I'll give this a shot. In this case, I'll try another 2 just to see what happens. 1 here, this is a 2, a 4, and then this becomes an 8 and a 6, and oh by golly, 2 worked again. So we end up with another 0. That means that 2 worked a second time. And keep in mind here now that we've got x squared plus 4x plus 6, which is left over. And what we ended up with is x minus 2. I'm going to put a square on that because we found both this 2 and this 2 to divide. So now we've got that. And here we can use the quadratic formula or factoring. Obviously, that's not a factorable quadratic, so we'd use the quadratic formula to finish that out. So let's move on. As you recall, I did that by factoring, but in this case, we have an example that doesn't look too easily factorable, but let's just take a look at it, and afterwards we'll see if we could have factored that. I know that the number 9 is the last term, so plus or minus 1 or 3 or 9. So let's take a quick peek across. 1, -3, -8, 21, and 9. One of the first properties that we saw was if all of these coefficients add up to 0, then the number 1 works. This does not happen. It's going to be a positive remainder. We'll put a plus right over the 1. However, you might notice that if we add up the 9, the 8, the 3, and the 1, those 4 numbers do add up to 21. It's just that they've got a sign of negative. So I'm going to just try a -1 and see what happens. If I put a -1 here, excuse me, -1 is my divisor here. I'm going to divide that, multiply through, I get -1 or -4 here. Multiply again, I get a +4, -4 here. Multiply again, I get +4, 25, -25. So I get a negative remainder. I'm going to put a negative right there. Now, even though that is not a solution, it does tell me something. It tells me that there must have been a sign change between 1 and -1. Notice this was a positive remainder, and -1 gave me a negative remainder. And we don't have any numbers between 1 and -1, so we're stuck with this one. We know that there's going to be some sort of irrational. I'm going to write that on the side. And that irrational between x between -1 and 1. So just keep that in mind. So it looks like that didn't work. I'm going to go ahead and erase this and start again. And we're just going to erase this line right here. Take this out and start again. See if we can get something to work here. So let's try a different value. Let's try the 3. See what happens here. If I take the 3, I end up with a 0 here. This is going to be a 0, -8, -24, -3, and -9 gives me the 0 that I'm looking for. So I've got that one to work. And so I do find one, the number 3. Keep in mind that that's an x minus 3. I'll just put that out here as a factor. Now I've got this next term, which is a 1, 0, -8, -3. And once again, I see that I've reduced that last term to plus or minus 1, plus or minus 3. I already know that the 1 produced a positive remainder, the negative 1 a negative remainder, and my 3 did work, so it's possible that 3 could work again. Let's give it a shot. Put a 1 here. This is a 3. 3, we'll try it one more time. This is 9. 1, and by golly, it does. So I'm going to put this down as kind of a lucky win for us. We've got an x minus 3. We have another x minus 3. That's from this guy right here, giving me a squared, and then an x squared plus 3x plus 1. And I get the feeling that this one's not going to have any more real roots because of my b squared minus 4ac being less than 0. Oh, wait a minute. Maybe it will. I guess it will. We'll use the quadratic formula for that one. So keep that in mind. If b squared minus 4ac is less than 0, then you don't have to deal with it. But in this case, it looks like you do have to work that one out. It's going to be some sort of radical 5 in that quadratic formula. I'm not going to do the quadratics. We're just going to move along and keep working these out. Let's go to the next one. This one is much trickier because you've got a 30 as your first term, and you've got a 24 for your second term. And so that's a real pain. And keep in mind, I've got these a little bit upside down, I must say. The 24 and the 30 have to be in the form where the factors of 24 are in the numerator and the factors of 30 in the denominator. So plus or minus, and then it's got a bunch of values. But before I do any of that, I'm going to check my values of 24. So let's just give this a shot. Here's a 30. Here's a negative 49. Here's a negative 10, and then a positive 24. Okay, so it looks like this one's going to be real trouble. Um, Not exactly sure where we want to go with this, but let's just take our 1 and 2, and don't forget there's a 3 and a 4 as our values. We're not going to test a whole lot here, but we see right away that if we add the 2 together, the 30 and the 24 adds to 54, and this adds to negative 59. So that's going to give us a negative for our 1. Now, if we try this with a 2, then we're going to get this. 30 here, this will be 60, this will be a 21, and then a positive 42. This is a positive number, that's a positive, and that's a positive. So this gives us our first rule right here. Got a nice rule, plus, plus, plus. It's called an upper bound. Okay, what this tells us is that because all those were plus, I don't have to try any numbers greater than that one. So here's a 2. I got a plus here, and I don't have to try any more of these. I'm just going to put an X right there. All those factors I don't have to try. However, you also notice that we've got ourselves a plus-minus situation here. So we must have perhaps a rational root between 1 and 2. So this is a very difficult problem. I've made this about as hard as I could possibly make it. I've got all the factors of 24, so that's going to be 1, 2, 3, 4, 6, 8, 12, and 24. And then I've got all the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. And I'm going to just look down the line and see, are there any fractions that I could make up with these numbers that are between 1 and 2? So let's see if we could figure some out. Obviously, 3 over 2 could be created. I see a 6 over 5. I see an 8 over 5. And I also see anything else there? I was going to say 8/3, but that's not going to work. So I think I have these 3. Oh, I'm sorry, I've got one more, 4/3. I see that one as well. I've got a bunch of fractions. So we're going to have to test those fractions to see if we've got something in between 1 and 2. Right, so that's going to be very tricky. Now, I'm kind of bored with this already. I don't even want to do it, but I do see that that's my real possibility. There's one other thing that I can notice, and that is the fact that the y-intercept is positive 24, and that tells me that if I plug in a 0, I'll get positive, and so I have another sign change between 0 and 1. So it looks to me like this graph is going to be having a couple of very particular roots between 1 and 2 and between 0 and 1. So just for fun, let's go ahead and try one of these and see what happens. So let's take the 3 halves maybe. 30, negative 49, negative 10, and 24. And I'm crossing my fingers. So here's 30. It's going to be 45. That's going to be negative 4. See a negative 6, negative 16, and then negative, oh by golly, 24, and I just nailed it. Wow, how did that happen? Totally lucky guess. So I'll show you what happens after this. So we got one to work. So we have an x minus 3 halves, and we've got a 30x squared minus 4x minus 16, and I'd like to show you how I can simplify this a little bit. I'm going to factor out a 2 out of that second term, and I'm going to jump that 2 over into the other binomial. So once again, I'm factoring a 2 out, and I'm going to jump it into the other one. That'll give me 2x minus 3 and 15x squared minus 2x minus 8 equals 0. Now, I'm thinking this might be factorable, so I'm going to just go on the side here, and I'm going to do my prime factor method and see what happens, and see if I can come up with a 2 in the middle. I think I can. I've got a 10 and I've got a 12, so I think I got this one factored no problem. Once we get that down into a quadratic, it's pretty easy to do. So we end up with 3x and a 5x. That's from those two right here and here. And then we've got the 4 goes with the 3, so that should be over there. And the 2 goes with the 5, that goes over there. We've got a 12, which is negative. This 2 should be positive. And now we've got the whole thing. And from here, you can just solve those individual binomials. Obviously, you can see here, this would have given us a 4/5 to test. And this would have given us a negative 2/3 to test. And this was a positive 3/2. So this was a nasty, nasty problem because all three of these were next to impossible. So what did we have to do? We had to go all the way back to the beginning and notice the sign changes right here between 1 and 2 and the sign change between 0 and 1, and that gave us the clues that we might have some rational roots there. As you can see, that is not an Algebra 2 problem. Let's do one more before we end this video. So this problem has a 6, 25, 21, and 10. Notice especially that the 6, the negative 25, and the positive 21 alternate, so I'm probably not going to want to try some negative numbers there because that's going to explode. So here I have a 10 and a 6. 1, 2, 5, and 10 are my values. If I add those values up, I see I'm just for 1, I'm going to end up with a positive return here. So guess I'll go ahead and try the number 2. See what happens. It's going to be a 12, negative 13, negative 26, negative 5, and negative 10. By golly, nailed it on the first try. Okay, so this one is much easier. It's got an x minus 2. Got a 6x squared minus 13x minus 5. And once again, hopefully this will be factorable. I can almost do that one in my head. So that's going to be a 3x and then a 5 and a 2x and a 1. And that looks like it's going to work for me. So once again, you can get these to work pretty fast. And again, don't forget to solve those binomials out. But look at what the other possibilities would have been. Negative 1/3 and positive 5/2 would have been the two values that would have worked. So it was kind of nice that we isolated the number 2 right away. So as you can see, these synthetic divisions get kind of nasty. I almost feel lucky that I was able to get these to work. Okay, let me finish out with this last one. I wasn't going to do a last one, but I'm still under the time that YouTube allows me to post, so I'm going to go ahead and nail this one. This is a 4 in the top and a 5 in the bottom, so we're looking at plus or minus 1 or 2 or 4. I'm not even going to deal with the fractions yet. Let's just take a look at this one. So it's going to be a 5, a negative 6, a 12, a negative 7, and a negative 4. And we're testing some values. Before we get all carried away, notice that the 5 and the 12 makes positive 17, and the negative 6 and these other two guys make a negative 17. So, oh man, I'm feeling really lucky here. I know that 1's going to work. 5 there. This will be a 5, negative 1. This will be a negative 1, 11. This will be 11. This will be 4. This will be 4, and this will be 0. So keep that little idea in mind that you can use that 1 when the coefficients add to 0. Now this time the coefficients don't add to 0, so I'm going to have to do a little bit of work here. I still have a positive remainder for 1. I'm going to try my best not to use a negative number because I see the alternation in the first 3 terms. So maybe something like a small positive number. This is going to be a little bit tricky, but I'll try. I'm going to try my old standby, that's 2, and see what happens. This is 5, then 10, 9, 18. As you can see, we're getting a lot of pluses here. So this is an upper bound for us one more time. So this is going to be positive and no more values to the right. So I think in this particular case, it looks like I'm going to want to test numbers that are very close to the origin or some very small negative numbers because, again, this is alternating, so we don't want to use negatives if possible. Let's try some of these values. So let's go down to here. We have 1, 2, and 4 in our numerator. We have 1 and 5 in our denominator. So we have 1/5 or 2/5 that could possibly work here. Maybe 4/5, but I kind of doubt 4/5 in this particular case. Let's give it a try with one of these other ones. How about we try 1/5 and just see what happens here. So if we take a 1/5, I'm going to erase some stuff. I'm going to erase this row here, and erase that, erase my answers. I'm going to start here with 1/5. So that would be 5. This would be 1, 0, 0, 11, and then 11/5, and that's unfortunate. And it looks like that's not going to work. So I am truly stumped on this one. I get the feeling I'm going to be at this a while. So what I'm going to do is I'm going to stop this video and I'm going to come back to it on the next video, and I'm going to start right where I left off here and see if we can get one of these to work or possibly some negative values right around the origin. All right, enough for now. Hopefully you're able to pick up some of these techniques as you practice these in the problem sets.